everyone. Welcome to our second session in chemistry for IGCSE students who are going to take their test on 2023 or through 2025. We started the previous session in chapter 1, states of matter, and we studied solids, liquids, and gases. We have some knowledge now about them and how they are related to each other, how their particles look like, and how they are different. Core students have 4 main topics, while extended or supplementary students will have 6 items or 6 topics. The first item for both core and supplement is state the distinguishing properties of solids, liquids, and gases. Second is describe the structures of solids, liquids, and gases in terms of particle separation, arrangement, and motion. Third, describe change of state in items of melting, in terms of melting, boiling, evaporating, freezing, and condensing. 4, describe the effect of temperature and pressure on the volume of a gas. Those are the main 4 topics for core students. In addition to this, for supplement, there are more 2 topics. The number 5th is explain change of state in terms of kinetic particle theory, including the interpretation of heating and cooling curves. Again, number 6, explain in terms of the kinetic particle theory, the effect of temperature and pressure on the volume of a gas. So those are the 6 items that we are going to deal with during our first chapter. And today we will be in the second session. We will see what is it about. Let us go and see. Considering the states of matter, how we can see matter in real life, how we can observe them. Are they the same as we see it as just physical or properties like or physical variants like solids, gas, and liquids, or we can also go further and do something else. Let us see here how we can see those in real life. Here we have a gas. This is the chlorine gas. It is a green gas and it is pure. And pure means it's made only of chlorine atoms bonded together to the molecule of the chlorine gas is made of 2 chlorine atoms. So it is clear, it is just one, it is pure. Here is the mercury. Mercury is an element. It is a metal, but at the same time it is liquid. So and it is pure in its pure form. It is just made of one type of atoms called mercury atom. Gold, especially 24 carats gold, is pure gold and is made of gold atoms only. There is nothing inside it. Silver also, it's very pure, and it's made of only especially this coin of Eisenhower, one of the presidents of the United States. It's made of pure silver. So it's only one type of atoms called silver atom or argentine atom. We have another types like the pure water. Water is pure. There is no impurities in it. It's not contaminated or polluted by any other substance. It is like the distilled water or any pure water. And it's made of two chemically interacted atoms, type of atoms, the two hydrogen atoms plus one oxygen atom. And at any time, if it is pure water, there is nothing but those two items. So it is a compound, but a pure compound. It is a compound, but a pure compound. Here we have sodium chloride, and here is the symbol of sodium chloride. It's made of natrium, which is sodium, plus chloride ion. Both together are bonded together chemically, and they made only one type of compound called sodium chloride. And here it is pure. It is nothing but sodium chloride. So it is a pure compound. Steel. Steel is made of more than one atom. It is made of mainly iron plus chromium and some sort of carbon together. It is a mixture, but if you cut anywhere, you are going to see the same number of atoms or the same number of distribution of these atoms. So it is a mixture, but it had a specific type of it, as it is some sort of homogeneous mixture. Here we have the air. The air. So the air is the mixture of gases. And pure air, that means there is no contamination of dust, there is no contamination of other materials, is a homogeneous mixture. Milk is some sort of colloids which are a homogeneous mixture. Here we have the seawater. The seawater, actually we have two types of seawater. We may have seawater that is pure and also homogeneous, but also we may have seawater with contaminants, with different types of contaminants and impurities, and this could be a heterogeneous mixture. So in real life, we may see elements like these elements, chlorine, mercury, silver, or gold. They are made of atoms, and we have around 115 element in the periodic table. It will come a time that we will go through this and see how they are different. And we may have compounds, which are chemical products, um, and they are made of different types of atoms, which are chemically uh, attached to each other or linked to each other, and they are pure. In their pure form, they are pure compounds. Also, we may have some mixtures, and we have two types of mixtures, either a homogeneous mixture or a heterogeneous mixture. By homogeneous mixture means at any time you take a part of it, you are going to find the same number, the same distribution of atoms at any time in any place. But if there is other things added to it, or the mixture are not highly blended, we may have a heterogeneous type of mixture. That means we may have a mixture that when we take part of it to and analyze it, we are not going to find the same percentage of contribution of their components. So those are the differences between them. And from here on, we are going to see how this is working and how it affects our study of chemistry. Let us take a break of a couple of seconds. As we said in the previous section, that we have some matters that are pure and others that they are blenders or mixtures. And those mixtures may be heterogeneous or homogeneous. Homogeneous, that means whenever you test them, the percentage is the same of everyone. But when you say homogeneous, heterogeneous, that means there is a difference in it. Now let us go and classify matter based on its purity. Purity is a very important characteristics of matter. So now we would like to classify matter based on its purity. Now, pure substance, first, a pure substance consists of only one substance without any contaminating impurities. So it is by itself pure because it consists of one substance. Okay? We did not define what substance is yet, but it is only one substance. If it is two or more, it's a mixture. But if it is one substance, it is a pure substance. A pure substance melts and boils at a definite temperature or definite temperatures. That means if we take, for example, water as an example, in any part, if it is pure water, in any part in the world, at any time, you take water, this water melt, you mean ice formed of pure water is going to melt at 0 degrees centigrade or 0 degrees Celsius. It boils at, when it becomes water and you continue to elevate the heat or increase heat and reach the boiling point, if it reaches 100 degrees Celsius, it's gonna boil. So there is nothing but boiling. And this happens anytime, if it's pure water, anytime, anywhere, anytime, anywhere, at any place, regardless of the amount of water you take it. A pure substance number 3 can be an element like a gold. That means it is composed of one type of atoms. One type of atoms. It's like gold, silver, mercury, chlorine, oxygen. It is just only one type of atom. I didn't say one atom, it's one type of atoms. Or a compound like sodium chloride. I'm talking about the pure one. Water, ammonia gas. All these are compounds made of different type of atoms. It's not one atom, it is different atoms, and they are chemically bonded. That means they are chemically attracted to each other. They are chemically tied to each other. A mixture substance consists of two or more substances mixed or blend together but not chemically combined. That is very important. They are not chemically combined. When you get sugar and you put it in tea and you stir it, it's going to mix together. You are not going to see the sugar, but it is just a physical blending, a physical stirring, and they are just mixed together using physical means. A mixture substance melts and boils at range of temperature because it's formed of different types of atoms, and each atom has its own melting and boiling point. So when they combine to each other, they have a range of melting. They do not melt the same time, the same way as a pure substance is. Different combination of mixtures may exist, like the solutions, the colloids, the emulsion, the alloys, the suspension. All these are types of mixtures, and we are going to see them in different places and through our study of chemistry. Let us try to compare pure substances to mixer substances and see if there is a difference or there are some differences between them or not. Let us go one by one. If we define each of them, we can say a pure substance consists of a single chemical element or compound without any contaminating impurities. At the same time, on the other side of the aisle, a mixture substance consists of two or more substances mixed or blend together but not chemically combined. So here we have a major difference. Categorization, categorizing each other, how we do that. So in case of pure substances, we categorize them into solid, liquid, and gas categories. While in mixture, we have only two categories, which are homogeneous mixture and heterogeneous mixture. Physical and chemical properties. They are very constant in case of pure substance, but they vary in their characters in between mixtures, and also they are vary even in the mixture itself. Because I can mix, for example, I can make a solution of salt solution, which is a mixture, 10%, and I can make it also 20%, and 50%. You can make it 50%. So those are different in case of their physical percentage-wise appearance or property. The same thing, chemically, they are different. Purity. Pure in case of pure substance, impure in case of mixture. Because you add 1 to 1. Even if there is nothing but only those two, still they are not pure because each one contains the other. Each one of them contains the other. For example, if we mix oil to water, this is some sort of a mixture, but it's impure because it is neither a water nor an oil. Separation, how I can separate them, whether it is pure or mixture. In case of pure, the only way to separate them is to use a chemical process, because you are decomposing it or break it down, never done by physical process. However, this is something different in case of mixture. We can use a physical process in order to separate them by using evaporation. If I have a salt solution, I just evaporate the water, then the salt is going to be on my beaker. If I have sand and iron, if I get magnetic bar, or if I have a magnetic bar, I can just pass it through the mixture and collect all the iron, left the sand away from the iron. By filtration, if I have sand in water, I just filtrate it, the water comes down while the sand is stopped there. By distillation is just evaporating the water by itself and leaving the others. By chromatography, this is a more advanced way to separate things, especially in case of protein bands. You can easily, by chromatography, use it and try to differentiate each protein and how much it takes. Then the last but not least property is melting and boiling temperature. It is definite temperature in pure substance. Each pure substance has its definite melting point and definite boiling point. On the other hand, it is a range. It's not fixed. It is a range, and the melting point of the mixture is lower than the pure, and the boiling point is higher. So the boiling point and the melting point could be used as a test to differentiate between substances, whether it is a pure substance or not pure substance. Okay, let us go forward. Here we are going to see what we have already. We are going to wrap or recap what we have seen, what we have studied just a few minutes ago. And we would like to do that in a chart form, so we can understand how we can deal with each one and how we can use and manipulate our information and present it in different ways, so it becomes in our stick on our minds. Here we have the matter. I'm going to use physical separation. If the physical separation is succeeded, that means this one is a mixture. If it isn't succeeded or it doesn't succeed, that means this is a pure substance. So by using physical separation processes, I may have a yes, that means it works, or no, that means it doesn't work. If it doesn't work, that means what we have is a pure substance. If it does work, that means we have a mixture. Now, if we go through this line to the end, now I'm going to use as chemical ways of separation to decompose my no physical one. So now, because why I use here chemical, because the physical doesn't work. So I'm going to use the chemical. Since I use the chemical, I'm going to try to use a chemical way in order to decompose this substance, the unknown substance. If the unknown substance is decomposed, that means broke down into different pieces, that means it is yes, it works. The substance is a compound. But if the chemical is not working, it doesn't work, and the answer is no, it doesn't work, that means I have a pure element like iron, oxygen, gold, and so on. Now let us go to the other side of the chart. Now if I have a mixture with the same composition, that means it is a yes answer. I have a homogeneous mixture. What I mean by the same composition, if I take a representative sample from any part of it, it is going to be of the same constituents and the same percentage, like this one. If I took this line, it's going to have 2 reds and 3 greens, while this one is going to be 2 green and 3 red. In every time I'm going to take one, I may have a ratio which may be different, but the same components are there. But if I have, they are not the same in composition. That means if I took differently from here or here or here, they are going to be different. The percentage may not be the same. I may lose one of the constituents. Anything that the answer will be no, that means I have a mixture, but this mixture is heterogeneous. Heterogeneous. That means it has different way of, not different way, it has different percentage if I took and examined it in each place of it. Now, this is to wrap up what we have just a few seconds before. Here we would like to see if the purity and impurity affect the melting and boiling points. Let us go for pure substance. We said that the melting and boiling points of the pure substance are definite, precise, and predictable, while they are vary in an impure substance. The most important thing that we can use, use them to determine the physical state, solid, liquid, or gas of a pure substance in relation to room temperature? Yes, we do. But we can't do that for case of the substance. And this is why I said before, that the melting and boiling tests are very important characteristics, and they determine whether this um, substance is pure or not, and also if it is pure, is it a solid, liquid, or gas? And I'm going to talk about this. Can be used to test the purity of a tested sample. So if I have a sample that I don't know whether it is a pure substance or not, using the melting and boiling points, I can do that. I can know if it is pure or not. But I can't do that in case of mixture. Now, here we said that the room temperature is 25 degrees Celsius. This is what we have had in the whole world, that the suitable temperature, room temperature, is 25 degrees Celsius. And everything is measured based on this temperature. So the room temperature, my room here, is 25 degrees Celsius. The temperature of it is 25 degrees Celsius. Now, if I have a tested substance, that means this substance, I don't know whether it is solid or gas or liquid. In what is condition? When it is at 25 degrees centigrade or Celsius. If the measuring temperature is 25 degrees centigrade, nothing above nor down. So neither above 25, not down 25. I would like to know the status of this substance at 25 degrees centigrade. So this is the main condition of this test. I will try to raise the temperature. I bring my apparatus and put it down and try to reach the melting point and also the boiling point. I would like to determine this. So if the substance melts below 25 degrees centigrade and boils above 25 degrees centigrade, this is a liquid at 25 degrees centigrade. Do you understand me? If I have a substance at degrees Celsius that is not 25 degrees Celsius, I don't know whether this is a pure substance or not. I don't know whether this substance at 25 degrees centigrade, which is the universal room temperature, at this temperature, what is the status of this? If it is pure, is it solid, is it liquid or gas? I'm going to follow that. Follow what? I'm going to heat this substance. The idea, the concept is to heat this substance. So if it melts below 25 degrees Celsius and boils above 25 degrees Celsius, that means the tested substance, the substance under investigation, is liquid at room temperature 25 degrees Celsius. Okay. If this substance I use heating and I keep raising heat, it doesn't melt at below 25 degrees centigrade. Then it goes up and up and up and up and melts above 25 degrees Celsius and boils above 25 degrees Celsius. Then this substance is pure substance, and at the same time it is solid at universal room temperature 25 degrees Celsius. If the tested substance is melted below 25 degrees centigrade and boils below 25 degrees Celsius, that means this tested substance at universal room temperature 25 degrees Celsius is a gas. I'm not going to write this, but I'm going to repeat it for the last time. I have three things to know that if it is solid or liquid or gas. And I have two things. If they happen, that means this is a pure substance, this is not a mixture. So if the tested substance, the substance under investigation, melted and boils or boiled at any degree Celsius, that means this is a pure substance. Again, to know whether the tested substance is pure, it has to do two things. It has a melting point, so it's going to melt, and a boiling point, that means it's going to boil. If during the heating it boils and melts, this is a pure substance. It might be an element, it might be a compound, this is another thing. But based on this fact, it is a substance. If there is no definite melting point or definite boiling point, that means this is a mixture. Now we finished knowing whether this is a mixture or a pure substance. Now, how I am going to find out whether this is a solid or gas or a liquid? First, the basic temperature at which I can say this status is one of the three physical status, it should be at universal room temperature, which is 25 degrees Celsius. Okay? Now, so what I have, my balance is the 25 degrees Celsius. Now, if I have a tested substance that melts below 25 degrees Celsius and boils above 25 degrees Celsius, that means this tested substance is a liquid at universal degree centigrade or room temperature, which is 25 degrees centigrade or Celsius. Now, let us move on. If I have a tested substance and this tested substance melts below 25 degrees centigrade and boils below 25 degrees centigrade, that means this tested substance at universal room temperature 25 degrees Celsius is in a gas status. It is a gas. Let us go further. If the tested substance has a melting point above 25 degrees centigrade and a boiling point above 25 degrees Celsius, that means this tested substance at universal room temperature 25 degrees centigrade is a solid substance. So by using melting and boiling, I know the purity of the substance, and I know also the status, whether it is solid, liquid, or gas. So melting and boiling points are very important. Let us go further. Now by this we finished a very good session, I think. I hope that I did well, and I appreciate your listening and patience. We finished to deal with the pure substances and pure mixtures, and how the melting points and the boiling points are important to determine whether this is a pure substance or a mixture, and also whether this pure substance, if it is a pure substance, is a solid, liquid, or gas. We will proceed. We are going for the kinetic theory after that, and also the heating curves, which needs more attention. Heating and cooling curves, which need more attention. It's going to face you here, face you also to some extent in biology, and also face you very strongly in physics if you are taking physics. So be careful. We will try to do it as the most easiest way. We will try to do it the most easiest way in order you understand, and by understanding you can manipulate your way of understanding, and also you manipulate your way of studying, and you manipulate the information that you have. Whatever they expose to you, you can really grab it very quickly and answer all the questions about it. Thank you for listening again. Thank you for this valuable time you give it to us, and I hope you enjoy this session. Thank you and have a good day.